Approach number 3 to make location decisions, the center of gravity approach. Now, the center of gravity approach is different from the other two approaches that we already discussed, because we can use this approach to identify a new alternative for a location. In the previous approaches, we already had existing alternatives and we evaluated these existing alternatives. In the center of gravity approach, we try to find a new potential location. And how to do this? We try to find the x and y coordinates of a new location by, similar to the low distance model, performing a weighting of the load that we need to transport to a coordinate. So the coordinate that we calculate in the center of gravity approach are for the x coordinate. We multiply all the loads that we need to transport to our customers times the coordinate of this customer, the x coordinate. And we repeat the same for the y coordinate. Load that we need to transport to a customer to the y coordinate. So let me make one remark on the notation. Though first of all, you see that I used the abbreviated, the short notation for the summation. That's clear because we are looking at all our customers. So what might confuse you as when you deal with this type of notation? Now I chose as the index I again. But this time I represents all our existing customers, all our existing locations. We are in the previous example, in the low distance model, the existing locations were represented by J, not by I. Though this can change quickly, it is not defined once and for all and then kept for all the whole lecture the same. Usually we use these indices I, J, K, L only as a placeholder, which has a meaning in each specific context. So you always need to adjust your context and have a look at this meaning. Though it makes absolutely no sense to memorize these formulas with I, J, K, L as indices, because it can change depending on the situation rather quickly. So by doing this approach, by calculating the x and y coordinates, we find one point, and this point is called the center of gravity. What can happen in practice that at this point we are not really able to open a facility? It might be in the middle of nowhere, not connected to the road network. It might be inside a residential area or whatever that is not suitable to open a facility. But at least we have identified an area where which seems very reasonable, and maybe we find a suitable location around this area. Though this is the purpose of the center of gravity approach, to identify a new location that might be useful. Now let's continue the example of the low distance model. I'm using the same data, I'm using the same problem data with the given load and the coordinates of the different cities. So these are our 4 cities. We have the transport load, the amount of goods that need to be transported to these stores in these cities. And now I calculate in this column the coordinate of the center of gravity for the x coordinate, and here I calculate the y coordinate of the center of gravity. I calculate the load times 11, which is the x coordinate of, what is it, Cleveland. I calculate 4 times 3, because 3 is the x coordinate of Dayton, and the result is 12. I repeat this process for the y coordinate. So for example, this is 70 times 10 equals 7. 7 times 10 equals 70. And I sum up the values in the x and y column and get to these points. The total load is again also the summation of the load of each individual cities. And then I can calculate the x-coordinate of the center of gravity. I call it CG. And the x-coordinate is 7.9 and the y-coordinate is 10.6. So let's go back to the example with the map and try to locate this point on the map. So we have roughly 8 and roughly 10.5. Let's go back to our map. So on the x-coordinate 8 and the y-coordinate is roughly 10.5. Though at the, oh no, it's not. Roughly here. This would be the center of gravity, and this would be the location where we should look for a possible place where we can have our facility in this coordinate. And you see it is quite close in this belt of, on this curve of cities, and it takes the transport volumes into account. Though the load distance model evaluates existing locations, and the center of gravity approach tries to identify a new location that we can use.